Hello, chemists. Welcome to our sixth investigation of the quarter. We only have 7 investigations this quarter, so this is the second to last investigation. It's actually our 7th week officially of the quarter, but we took that week off for MEA, and now we're back at it doing our 6th investigation. We're going to start looking at some chemical reactions this week and try to describe them. As chemists do. We're going to look at a bunch of them and then try to write chemical equations. That's our main thing. Look at some chemical reactions and then write chemical equations. That's our goal. Same old thing as usual. We've got our 5 assignments that we have to do. And then the one thing that I'd like to point out that's different, no, there's two. There's 2 things. First thing is that for the initial video, I'm asking you to do a very specific thing. For your initial video, I'd like you to do an example reaction for me. You've got a bunch of reactions to do for the overall investigation, but I'd like you to do one of them as an example for me for your initial video so I know that you're on the right track. Just don't use my example of magnesium oxide as your example. Use something else. No big deal, same old thing. You click on the introduction to resources and you end up with this document that has all the information that you could need. It has the introduction with all the big words that you need to know, and then it has the instructions. And this one I did do instructions where you go instructions as you go along, trying to walk you through it. And then I have the main questions that you're trying to answer in bold. Okay, so, and then I also mentioned for your initial video, choose one reaction and show me that you can do steps 4 and 5 for that reaction. Okay, and there's no warnings or safety for this one. Okay, let's get into me trying to explain what in the world this stuff is. Okay, so just to give you an introduction to equations and how chemists use symbols and formulas and equations, just kind of give you, we've been working with symbols and formulas, but I just thought I'd just make it a little bit more structured and then introduce equations to you. So let's just look at this just as kind of a review. These are the symbols for elements. Carbon has a symbol of C, hydrogen has a symbol of H, oxygen has a symbol of O. You could say copper has a symbol of Cu, and they're just each one atom. And sometimes when we draw models of atoms and molecules and compounds, we'll have an atom be just a little circle of a different color, and it shows that it's a different atom than the other ones. Now, is carbon actually this color? No, really, of course not. But, it's just a model that helps us picture what's going on. So elements are found in the periodic table, and it's the smallest thing that has all of the properties of that element. So carbon, one atom of it will react in the same way as 30 carbon atoms. They all have the same properties. Okay, so let's look at a little different. Here we have our symbols and atoms. And over here we have molecules or compounds. And the difference is that molecules and compounds have more than one atom chemically bonded together. So the atoms are attracted to each other, they stick together, and they're stuck together by these bonds, and that is what is holding them together, and they have a formula. And so molecules or compounds have formulas. You notice this is O2, it has 2 oxygens stuck together. So these little numbers mean that that atom, there's 2 atoms in the molecule and they are stuck together. So here we have two H's stuck together to an oxygen. They're all stuck together. And here we have 1 carbon, because it doesn't have a number after it. We assume that if it doesn't have a number, it's 1. We have 1 carbon stuck to 4 hydrogens, all stuck together, chemically attracted together. And those are different molecules. Okay, so you might be like, okay, got it. That's easy. But a lot of people have trouble with the differences here. You guys got it pretty good last week when I did the little test for you, but let's just kind of review So let's look at what's the difference between this one here, capital C, little o, and capital C and capital O. You're like, who cares? What does it really make that much of a difference? I mean, come on. And I'm just going to, and then you could look at this one like capital C, capital U, capital C, lowercase u. Does that matter? Does it really make a difference if you have one carbon and one oxygen or one carbon and two oxygens? Who cares? It's still carbon and oxygen. And you might be like, yeah, that doesn't seem like that big of a deal, but it does matter because these are symbols, and I'll just show you why. This CO is the symbol for cobalt. It's just one little atom of cobalt, which is a metal that's in all kinds of alloys and stuff. And this is carbon and oxygen bonded together. A carbon, here's a carbon, and there's the, okay, either way, it doesn't matter, carbon and oxygen. And this is carbon monoxide. This is a gas that can kill you. So cobalt metal atom is a very different than a carbon monoxide gas compound. So here we've got carbon monoxide kills you. This is just a metal. And this is copper and uranium stuck together. It kind of doesn't exist, but you know, just for the point of it, this would be carbon and uranium stuck together. These two atoms stuck together chemically, whereas this is just copper. This Cu is a copper metal atom, and this is carbon and uranium stuck together. Totally different things, right? And here I've got carbon and oxygen. Here's that same thing. We've got carbon monoxide, a carbon and an oxygen stuck together, and that's carbon monoxide, totally kills you. And then you got carbon dioxide, which is the gas that you breathe out every time you breathe. So one of them kills you, one of them is, well, it'll eventually, if you get too much of it, if you're in a room full of nothing but carbon dioxide, you would die. But carbon monoxide, even in small amounts, will kill you. So carbon monoxide, the stuff you breathe out, carbon monoxide kills you. And all that's different is that this one has one extra oxygen. It has two oxygens instead of just the one. All right, so let's look at these ones. You might be like, okay, we get it. If the formulas are different, they should be different. But I just want to hammer this home. Here we have O2, and here is O3. This is oxygen that you breathe like you'll die without it if you don't have it. And this is ozone. O3 is ozone, and this is like a common pollutant. And it's the it's a really burny, it's a gas that burns your eyes and your mucous membranes, and it's not good for your lungs. It aggravates asthma. All kinds of things are bad about ozone. It also is really good at killing bacteria and stuff, so they use it to kill stuff. But it's also hard on you because you're alive as well. So we got water, H2 hydrogens and one oxygen, two hydrogens and one oxygen. And then we also could have two hydrogens and two oxygen. You'd be like, oh, why would it matter if you have one dumb extra oxygen? That doesn't seem that big of a deal, right? I mean, it's just one extra oxygen, but this is water, which you need to live, and this is hydrogen peroxide, which even, the stuff that you buy from the pharmacy that's like 3% hydrogen peroxide, that'll like bleach your hair and bleach your skin. And if you get 30% hydrogen peroxide, that stuff can actually it can be really strong and damage your tissues, which is why it bleaches hair and bleaches your skin, because it's really good at damaging tissues. Anyway, that's hydrogen peroxide. One extra oxygen makes a huge difference. So you might say, okay, well, the H2, well, how is that different from H? Well, the fact is that H very seldom is around in the air, whereas H2 is hydrogen gas. That's how hydrogen gas is usually found. You don't find it just floating around as one hydrogen by itself. You find it as two hydrogens stuck together. So it does make a difference. The formulas make a difference. Okay, so let's go over and look at a reaction. So this is what you're going to be doing this week. You're going to look at a video. I'm going to model how to do this how to do one of these reactions for you. So let's go over to the video of magnesium metal burning with oxygen gas.
Here we have a ribbon of magnesium. Magnesium is a metal, has the properties of luster. You can see it's shiny, it's malleable, it's bendable, can conduct heat and electricity. So what we're going to do is we're going to try to react this magnesium with the oxygen in the air. We need a little activation energy to get the magnesium to react with the oxygen, and there it is. So oxygen's reacting with the magnesium ribbon, and it's releasing a lot of light and heat energy. This is one of the brightest lights that is produced by a chemical reaction. They often use magnesium in fireworks for these bright bursts of white light. And also is extremely hot. You can get very, very, very high temperatures from this chemical reaction. Now, coming off the light, you can see a white ribbon, and that is the magnesium oxide that's being produced. So magnesium atoms are being bonded to the oxygen atoms in the air to form in that magnesium oxide product. Now we have an up-close look at the magnesium oxide. You can see it has a white color, that's one of the properties, and you can see it's very brittle. Basically it's going to turn into a powder if you touch it. How do magnesium atoms bond with oxygen atoms? Well, let's take a look at how all that works.
And you guys can finish that video if you want to see how that works. But so in order to make to do what we need to do this week, talking about, okay, so we saw that reaction. We saw the magnesium metal and the oxygen react together, and that's what this arrow means. You take this plus this, they react together, and you end up with a product, and we're saying that that product is magnesium oxide. And you guys are able to figure out the formula of magnesium oxide. I'm going to tell you that it is 1 magnesium and 1 oxygen. That is the formula for magnesium oxide. And now let's look at this, and what do you know about the, So let's look at this and go, okay, do we have all of the formulas correct? I just told you that magnesium oxide is 1 magnesium and 1 oxygen. You can use your valence electrons or charge to figure out whether that's true, or look back to last week's experiment to see that. But let's just make sure that all of our other formulas are correct. We know that magnesium metal is just magnesium metal, but now oxygen, I'm just going to tell you that oxygen, there's a reason you always hear O2 when people talk about oxygen, and it is because oxygen is actually a pair of oxygens stuck together. They're attracted to each other, and oxygen is we call that a diatomic element. It has 2 atoms in the element. The element is not found just 1 oxygen atom floating by itself. It always is found as a pair of atoms when it's a gas as an element. So there we have O2, and that's why it's O2. And let's look at some of the other ones that are found like that. Notice that we've got nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. And way over here is hydrogen. There's a couple ways. These are all diatomic elements. They're all found as pairs of atoms when they're found in their element form. When they're just an element all by themselves, they pair up in these pairs. And we're going to see a lot of these pairs in our formula, so I need you to be able to remember which one these are. So you can find them on the periodic table. One way I think of it is, if you know that oxygen is O2, you know that it's part of this hockey stick, and then there's this puck. You know, you could think of it like the hockey stick and the puck, or you could think of it as 7 and 1. So 1, 2, 3, 4, 5, 6, 7 and 1 element. So there's a 7 and a 1. Those are all the diatomic elements, however you want to remember them, or you can just look it up, the diatomic elements. So all of these guys, all when they are found as elements, they will be found as pairs. When they react with other stuff, it's a whole nother matter, and we'll see that. You notice there isn't 2 oxygens over here in the oxide. It's just 1 magnesium and 1 oxygen. It's because of their valence electrons and their charge. So we've got our formulas correct. And now let's look at, what did you see in the video? What were the properties of magnesium? And hopefully you saw he talked about that it was conducted electricity and that it was malleable and very flexible, and we saw that it had that metallic luster. So I mean, it was very clear that magnesium was a metal. And then oxygen, well, now he didn't show a whole lot about oxygen, but what do you know about oxygen? Oxygen is 20% of the air that we breathe. So a lot of the air that we're breathing, well, a lot of it is nitrogen, N2, but 20% is oxygen. So that means that oxygen is a gas, first of all, at room temperature. It is also colorless. You can't see it in the air. It's a colorless gas at room temperature. So those are some of the properties. We know that oxygen is also a non-metal. It is not a metal. So it is non-metal. We have a metal and a non-metal reacting to make a salt or an ionic compound. So we've got this magnesium oxide. Okay, so what are the properties of the magnesium oxide? Is it metallic? Is it a gas? Does it have any of the properties of the reactants? And I'm hoping that you notice that it looks like a salt. It was brittle. It was white. It was a white, brittle powder. So the products of the magnesium oxide salt is totally different from the products of reactants. That's one of the reasons we can tell that a reaction has happened, is because all the properties of the stuff that we started with changed into totally different properties of the things that it turned into, the products. And now we also know that there was a reaction because there was this crazy big flame. And yeah, right. So like this arrow is when that flame was happening, when that reaction, when all the switching, all these magnesiums are tearing apart these oxygens and bonding with an oxygen. So that's what's happening. All that switching partners, that's what's happening during the reaction. And while that switching is happening, the breaking of bonds and making of bonds, all that changing is when we see the flames. There's a change in energy when we have this reaction. The reaction is happening when we have all those flames. Okay, so that's what we see. But I want to point out that we're not done. We've done a lot of the stuff that we already able to. Now we're getting to the stuff that you don't know how to do. Writing chemical equations. And first of all, we've got magnesium here, we've got our O2, and we got magnesium oxide. And I want you to notice that there is only 1 magnesium, there's 2 oxygens on this side, the reactant side. And you notice we only have 1 oxygen and one magnesium over here on the product side. And that means we have 3 total atoms on this side and only 2 total atoms on that side. And that means that they're not balanced. Like, where did this oxygen go? Did it just disappear? And I'm just going to tell you that that's not possible. If you don't have the same number of atoms on one side, on the reactant side, as on the product side, something went wrong. We are breaking the law of conservation of mass. The law of conservation of mass, if I paraphrase, is you can't make something out of nothing. And the corollary of that is stuff just doesn't disappear. You can go look up the actual words of the law of conservation of mass, but that's really what it is. You can't make something out of nothing, and stuff just doesn't disappear. So in order to make the law of conservation of mass work with these equations, I want to just use something that you've seen before, and you've kind of done this puzzle before. If you've ever been at a barbecue and you have to bring brats and buns, inevitably you go to the store and they give you 4 brats in a package, but they never sell 4 buns in a package. It's always 6 or 8, and then, or else you can get 6 brats. It just, for some reason, I never can find the same number of brats in a package as the same number of buns. They always sell them in different amounts. So I'm going to just use this barbecue analogy to try to help us understand how we balance equations. Okay, so we start out, this is a brat 4. There are 4 brats combined or attracted or bonded together, right? 4 brats bonded together, and here we have 6 buns in a bag bonded together, right? So buns come in 6, brats come in 4. So and then what you want to make is a brat bun. You know, you want 1 brat and 1 bun stuck together, and then you get to eat them, and that's how you want them. But right now, do you notice our equation is not balanced? That is a problem. We have 4 brats on this side and 6 buns on this side. First of all, those don't equal, which is a problem. And then the other problem is I only have 1 brat and 1 bun on this side. That's just, where did they all go? I mean, did some dog eat them? It's just, we want this to be equal. Otherwise, it doesn't make any sense. So in order to fix that, we balance the equation. Let me show you how I did that. You can probably work it out yourself. But if I take 3 brat packages, you know, 3, we got a brat 4, a brat 4, a brat 4, and we take 3 of them, we have a total of 12 brats on this side of the equation. Okay, and I have, if I take 2 packages of buns, and you see this number is the number of packages of buns. I didn't change this number. The buns still come in packs of 6. The brats still come in packs of 4. That doesn't change, but I changed the number of packs I take, and I changed the number of bags of buns. And so I have 2 buns, 2 bags of buns. And do you notice that 2 bags with 6 of them is 12 total buns on this side? And you see how if I have 12 brats on this side and 12 buns on this side, that means I can make 12 brat buns, which is very exciting, with no waste at all. There's no extra buns hanging out. There's no that you have to like somehow make a sandwich out of with some other thing, you know, put potato salad in that bun, gross. Anyway, no, you actually, and you don't have any leftover brats without buns. It's so much better. So we have the exact same number of brats on this side of reactants, and we have the same number of brats on the products. Same thing, say 12 brats, 12 brats, 12 buns, 12 buns, everything balances out. This is a balanced chemical equation. Okay, let's do the same thing with our magnesium and oxygen. Here we have magnesium, 1 magnesium atom. We have 2 magnesium atoms bonded together. This is the bonded together thing. And then we have a magnesium and an oxygen bonded together. We have Mg and O shows that they are stuck together. Okay, but the problem is, you notice that it's not balanced. We have 1 magnesium and 2 oxygens on this side, and 1 magnesium and 1 oxygen on this side. Not okay. It's not balanced. We need this to be balanced. So what we need to do, we can't change the formulas. This, I can't make this be Mg2. That doesn't work. It doesn't come that way. I can't change this to O2, MgO2. That's not magnesium oxide's formula. We can't change that. But what we can do is we can change the numbers in front of our formulas. I can change the number of packs, the number of packages of our compounds. And how I do that let's just show you, I could have 2 of these magnesiums. Hey, that's 2 magnesiums. I just have 2 of them. I didn't bond them together or anything. And then I still have my 2 oxygens. They're still bonded together. Nothing changed there. But then now I have 2 magnesium oxide compounds, 2 magnesiums and 2 oxygens. I got 2 and 2 and 2 and 2. It is balanced. I have the same number of atoms on the reactant side and the same number of atoms on the product side. They equal each other. So let's see how to write the formula then when we did that. What that does is we put a 2 in front of the magnesium. We didn't change the oxygen. And then we put a 2 in front of the magnesium oxide. That means I have 2 of these. And you notice the difference between these two is 2 magnesium means I have 2 of these atoms. They are not bonded together. And then O2 means that I have 2 oxygens bonded together. Okay, that is a balanced chemical equation. The last thing you can do is just to kind of give people an idea of what this equation looks like is you can add the states of matter. Let's just ask ourselves, what was magnesium? Was it a solid, a liquid, a gas, or was it dissolved in water when we saw that reaction? It was a metal, it was shiny. Was it, I'm going to say it's a solid. So magnesium was a solid, oxygen was a gas, and then magnesium oxide, well, it wasn't a metal anymore, it wasn't shiny, but it was a solid powder, a white powder, so that was still a solid. So we add our states of matter, and here's our solid magnesium, our gas oxygen, and our solid magnesium oxide. And that just kind of helps people picture what the reaction looks like. And there we have a perfectly balanced chemical equation. Okay, so the steps for writing the balanced equations: write the correct formulas for the reactants, and watching out for those diatomic elements. If it is one of the diatomic elements, make sure you write that down as a diatomic element. Write the correct formulas for all the products, and that is, in this case, it's all the salts. Remember how to balance, make a formula that has the charges neutralized or balanced, make the charges balanced, or you can use your valence electrons to help you figure out what the formula is. You can also look on the periodic table and see what the formula is for the thing. And then once you figure out all the formulas for the reactants and the products, number 3, please don't change the formulas. I'd shout it, but it will hurt your ears. Don't change the formulas. Just keep them the way they are. So then if you want to change it so that you have the same number of atoms on the reactants and the products, just change the number in front of the formulas until the number of all the atoms equal the number of the reactants equal the number in the products. So we're changing these numbers in front instead of changing these numbers. Okay, that's it. Then you're going to go to try balancing equations with the practice simulations. I'm just going to point out that the game level 1 is perfectly good for you guys. Level 2 and 3 are kind of hard for you guys, and it's more than we need to do. We'll be doing the level 2 and 3 later on next semester. So let's go to the practice simulations. You click on here. Here we've got our balancing chemical equations. You do the introduction, and you can see how there's a couple of different tools here. You can use this one if it helps you to picture like how many nitrogens are on the product side and the nitrogens on the, notice that the nitrogens are going to change when I change it on the, here's the reactants. I have 2 nitrogens on the reactant side, but if I increase this, I'm going to have 1 nitrogen on the product side. Oh, and look, there's 3 hydrogens on this side. So reactants and products, reactants and products. And then you can change them until they balance. Oh, I've just made it all messed up. Oh, I don't know. Anyway, you can figure out how to balance it. The other tool that I think is actually kind of useful for me, I use this. These are the elements on the on the reactant side, and then this kind of the way I was picturing it is this way, and you can try that. So either one of those tools are good. You can try that or that, and that works great. And then try the level 1 game to test yourself. Okay, so for your initial video, the last thing is I pretty much did magnesium oxide, magnesium reacting with oxygen, making magnesium oxide. I did these things for you. I figured out which was the metal, whether it was a liquid or a gas, figured out what the properties of the nonmetal are. We figured out what was happening during the reaction. We talked about how there was a big flame, and that's when the reaction was happening. That bright light was when the reaction was happening. And then we figured out what ionic compound was produced. We talked about the physical properties that you saw, and then we figured out what the formula of the ionic compound should be. And then we wrote a balanced chemical equation for the reaction. So I did magnesium oxide. For your initial video, you pick any one of those, I'm going to scroll down to here, any one of these reactions, pick a video, and do those steps for me for your initial video, and show me that you understand how to do those steps. And that is it.